This one more presentation from SUT Plus. I'm Renata Carvalhal. I'm a SUT ambassador. And we invited Eduardo to do this presentation for us. Thank you so much for accepting the invitation and to prepare this presentation today. A little bit about Eduardo. I had an opportunity to work alongside him in a few projects back in Rio office, WoodBrazilian office, and I can say that when you have something repetitive, you can do something repetitive, but not Eduardo. He always have tips on how to make it different and make it better, make it more efficient. So. And he has years of experience in structural engineering, a vast experience in computer software, engineering software. But I won't go much further. I'm sure he wants to introduce himself in a better way. So thank you again. With you.
Hi, good afternoon all. Good morning for anyway, wherever you are, good night. So thanks for attending. Today I'm going to talk about the practical use of programming in engineering. And as Renata said, how the knowledge of programming and coding can help our daily routine. So moving on. So yeah, let me introduce myself. As Renata said, my name is Eduardo Tenorio Bastos. I'm a civil engineer, structural specialist. I graduated in 2008 at the Federal University of Rio de Janeiro. I have a master's degree in structures in that same university and work in the oil and gas industry, or may say energy industry, since 2006 and joined Wood in 2016 in Rio office. Moved to Aberdeen in late 2019. It's where I live now. I learned code around 2003. I was at university still. And then I used many programming languages such as Pascal, Fortran, eventually Python. But it's important to highlight that I am an engineer. I have always been and hopefully will always be an engineer. I'm not a programmer. I use programming, as I see, is a tool to make our life easier, and that's the view I'll try to share to you. My goal here is to motivate any of you to try to learn, not to become a programmer, but to learn some programming to work better as an engineer. So an overview of this presentation is, as I said, my main objective is to motivate other engineers of any level of experience to start or deepen their programming skills. No matter if you just finished university or if you still haven't finished, or if you're an experienced engineer, it applies to all. So who is this presentation for? I mean, for every engineer that's somewhat keen for programming, and I'll try to show that any level of programming has its benefits, and there's no reason not to start. And maybe who's this presentation not for? I hope nobody, but just say it may be not so interesting for people that already know a lot about programming. I'm not, how can I say, I'll not explain programming in this presentation. What I want to do is to present how can you do things easier. So what I'm going to explain here is my view about programming, about its use in engineering, and showcase some examples. Not show off what I've done, but to show what you can do with a little programming knowledge or with a deep programming knowledge. Whatever suits you best can generate results. And at the end, I open to a Q&A session. So if you want, you can take notes and ask at the end. So please feel free to ask. There's no problem about asking questions. First, my overview about programming. So first, let's state what I understand by programming and why it's important for our routine as engineers. I don't want to give a formal definition of programming. I leave it to professors or book writers or people like that. Programming, as I see it, is a set of simple instructions that yield a result. So anything, any job that you can break down into smaller, simple tasks, it's programmable. Even to prepare a worksheet in Excel or MathCAD, if it's structured in a logical way, it's programming already. How do you program? The traditional way, you can learn a language, a programming language, anyone, and get used to a program environment and create code. Or, as I said, you can just create a worksheet if it's a good, well-structured worksheet that you input data, get a result. You're at programming. You are making easier your tasks. So what for? What will you use programming for? Well, the main thing is repetitive tasks. We have to do it all the time as engineers, is repetitive task. Or also when we deal with a large amount of data, which at the end of the day is also a repetitive task, dealing with a large amount of data. Our brain is really terrible at doing repetitive things without making mistakes. However, we are brilliant in recognizing patterns, and the computers are the opposite of that. So it's a perfect partnership if we use our capability of our brain to recognize a pattern, to translate that into a code, and let the computer repeat it over and over again without making mistakes. And the benefits so become clear. It saves time. All the engineer work is all about time. Our productivity is measured in hours, and that's how we get paid. If you can do 4 hours work in minutes, so yeah, you hit the jackpot. Also, it prevents errors. The less we work, it's also saving time. And sometimes you can save so much time that actually makes some work feasible, which will not be otherwise. I didn't write here, but another benefit is that it's fun. Believe me, it's quite fun to work on. About programming in engineering. So let's narrow now the subject, some practical applicability, and talk about some examples. The first I will show is a worksheet, a simple worksheet with no code, no macros. It's just designed like a program, just designed to look like a program to start with. Then I'm gonna showcase 2 Excel VBA codes, a macro and a formula code that for day-to-day tasks, it's wonderful. And not an example, but worth to mention, there are some softwares that have their own script language, namely ANSYS APDL, maybe is the most famous for structural engineers at least. And there are also AutoCAD, AutoLisp for drawings. And I'm not showing examples because they are very specific. And the point here is to be, broader. But if you know any programming language, you can adapt to that script language easily. But I believe personally that things like this are gonna disappear in the future and be replaced by the next bullet here, that's software that have Python interface or other language, but I think today it's Python, the most of them. I can name Abaqus and Orcaflex, but surely there are more. These softwares provide script environments similar to the Excel provide for VBA, when you can access the program features and objects and automate things from the inside. And this is what I believe will become more and more common. So is what I recommend to study and have an eye on. So let's get started. The first example is a simple worksheet. It's designed to look like a software. This one is used to calculate mechanical properties of a section that can be formed by rectangles. Who is civil or mechanical engineers will immediately recognize the utility of these. Many of us have already prepared some worksheets similar, but the point here is not the product itself, but the idea. Here it is, how it's look like. You can see the lighter cells represent the input data. There are some explanations, some calculations, and many will think, oh, I did a worksheet like this before. This is not a program. Yeah, this is the point. It's not a program, but if you design this to look like a software, it automates the task. You input data and later on, you got results. You got the section properties. You got a drawing of the section that you can use in reports. And there are many softwares out there to calculate section properties that looks exactly like this. And if you want to make a program, you have to worry about creating windows, creating buttons, menus, and blah, blah, blah. Many things that you don't have to worry about in Excel. For an engineer, you just want to give the input and get the results. So yeah, this, you can call it a software, that runs under Excel. This is the first point. And okay, good worksheets are already programmed. So, but yeah, it has its limitation. You can do much more. To step up, you must really learn some real coding. To unlock the potential of programming, you must code. So here I try to summarize what coding is about. The point here is just to show that it's not difficult, it's not complex as many people think it is. Coding is about 3 flow instructions that are if, for, and while. So the if is like fork in the road. You just decide if something's true, you go there. If something's false, you go all the way. And for and while are for the repetitive tasks we are talking about. Difference is that for a statement, you repeat something for a specific number of times. For instance, you solve some load cases. You have 10 load cases to solve. You know that you repeat your operation 10 times. In the while statement, you repeat something based on a condition that is satisfied. So while something is true, you keep doing what you're doing. For example, you are searching something on a list, you search until you find it. Or a numeric solver, you keep calculating until you reach precision. And syntax, it's not important. It varies for many languages, but you can Google it. If you know what you have to do, and you know how, which of these 3 flows you have to use, you Google the syntax and program, no worries. So first thing, or second thing actually, it's also in Excel for how to do a macro. Let's say some software produces its output in a text file that you want to post-process in Excel. You want that because you can post-process your data in one line and just drag down, repeat for all the cases, but your software produced the output in non-consecutive lines. So dragging down will produce lots of error lines. It's something I believe everyone came across at this issue at some point and wasted a lot of time selecting blank lines manually and deleting it, and so deleted some content unintentionally and lost information, so it was a nightmare. My point to show is that how it can be easy to just, in Excel you have that feature record macro, so you start recording, you do what you have to do for a couple of times, in this case deleting the lines, and stop recording, open the macro. So Excel gives here in the right hand side, in the top right hand, it writes just what you have done in code. So deleting the lines, you see whole 13 dots delete, selection dot delete. Okay, this is how it does it. So you put a loop around it. You change the numbers for variables, and you should have a rough knowledge of programming logic here to know what you have to use. You will use a while with if statement inside. So this is very basic. This is not optimized. This is not generic programming. It's an example of something you can do in minutes to perform an operation. Because if it's just this page that we are showing, okay, we can manually delete. It's not that work, but many times we're dealing with thousands of lines of result. So to do it 1,000 times, I doubt that you will be able to do that without making a mistake, without losing some information. And it's quite fast, easy to create by programming. So still in VBA, next example, it's a bit more advanced, but still easy. I mean, you can create formulas in Excel. Formula, I mean the formula that you use, like sum, like average, like the other native ones. The example here is for an integral calculus, and I choose this example because integral is something perfect for programming. Why? Because it's very difficult, it's very hard to solve analytically, and on the other hand, it's very easy to break down and use what we call the brute force algorithm. Is like the very definition of integral is to break down your domain in a large number of small parts and sum them up. So okay, just do that. There are other elegant algorithms to solve numerical integrals, but you always can use the brute force and leave the work to computers. The example here is, I don't want to stick to the engineering part of this, so it's just to explain what it means. There's the Boost-Nash equation. It calculates stress for a point load, and in reality, we never have a foundation calculation point loads. We always have loads in an area. So we should, from this equation, integrate that over an area. And I'm showing the equation just for you to see that you cannot do this analytically. At least I cannot do. So what some valuable engineers did in the past was to calculate it manually and create these book figures that we use today. So we get some parameters and you go to these graphs and take some coefficients and use. The problem is that you have to manually pick the coefficients from the graph. You cannot automate that. If things change during a project, or if you want to do a sensitivity study, it's a lot of work to do, or the dimensions change and you forget to change the coefficient. There's another solution. Here it is. I'm showing, again, I don't want to explain the algorithm here, just to show how it works and how it's easy to do. So here's the function as it was shown in the previous slide, and you can see 2 for loops for any number of divisions. So this is actually dividing our domain and summing up just the equation as it is. No complication, nothing very difficult to do. And if you look to the formula box on the left-hand side, there is that function sigma z that we just created in the previous slide. And you can use this function in Excel just like a native function. So you don't have to worry again about integration. It's inside the function. You just use it. So you can create this graph that's shown in the right-hand side for the area above, for many lengths, for many depths. Is the most simple or the most complex functions. You can just insert them and then use easily. Other examples will be something that I swear I use every single day, one of these. An interpolate function, for example. I have this graph for some pair of values, and I want to know any values in between. I have an interpolate function that does this so you don't have to do manually. Or a split text on the right-hand side, you see text file. It's an input for engineering software, and I want to split that in columns so we can work the values, or we can search, we can filter, we can do whatever we want in Excel. So the possibilities are endless here. Think, oh, if I can create a function in Excel, yes, you can. It's not a big deal. Lastly, so let's talk about Python. Let's talk about any programming language, really programming language, but I stick only with Python. With the examples presented before, we already can do many things to facilitate our work, but you rapidly feel that you can do much more. And so you have to learn a more comprehensive language to do so. It's a natural step, and it will give us the freedom to work with almost everything. And in my view, Python is the language of today. Of course, there are other good languages, but I recommend Python. It's my favorite. And why that? Mainly because of the availability. Python is free, even to use at work. It's friendly, it's flexible, it's widely documented on the internet. You can find any doubt you have, you can find it on the internet. It has a large number of libraries that are really accessible. It's not, oh, I heard that there is this library in Python. No, you just go on the internet and use. For us engineers, we have a numerical library, NumPy, to solve linear algebra, factor, matrix, statistics. You have a graph library from Matplotlib to create all kinds of graphs, and pandas to deal with data analytics. And we have also powerful 30-part libraries to work with Excel files, with PDF, with DXF, and it's perfect. For instance, you receive many tables of data for your project from the client in PDF. So we have PDF tables, and to extract the data from there, sometimes it's a nightmare. To copy and paste in Excel, it undo the format, and you can program something to go the files and read them and format whatever you want quickly and safely. And also to mention that engineering software interface like Orcaflex and the things that I'm going to showcase here. This is the last example. It's an Orcaflex analysis of pipeline installation. And just to illustrate again, I will not enter the engineering part of that. It's just to show these many load cases, trying a little variation of load cases. We almost get 500 load cases. So we have to analyze every possible combination of C-state, of wave direction, of installation parameters that we want, but we don't have time. In the project experience, the first thing we learn is that we never had enough time to do things. So what we usually do is to reduce the possible load cases as much as possible, to narrow the load cases. And the problem is that we have to be conservative when do this. We restrict the operation. So the more analysis we can do, the less restrictive we can be, and so generate value from the client. Because an operation halted is the worst thing that any operator wants. Load case described here is just to illustrate the quantity of load cases we have to deal with. And okay, so what we discussed before, we could already create what I call an outside programming. So we can use a worksheet, a well-structured or macro worksheet to generate input files, to use a batch run and program, and then post-processing the generated outputs. But what I point here, it's already good. It already enables us to do many things, but we are still dealing with large amount of data. Input files, this is time domain analysis. So you have a time history output. It's sometimes about 10 megabytes of input files, 100 megabytes of output files. With that 500 cases, we're talking about 50 to 100 gigabytes of files. And sometimes we run out of disk space. And even if you have space, reading and writing on disk it's very, very time consuming. It's the slowest operation for computers. And the advantage of the Python interface is that it offers access to the program features, just like if you were on the user interface. You are on the screen, you open a window, change the web height, for example, click OK and run. You look at the result, it generates a bunch of results, but you take only what you need. And then you change the web height, run again, see what changes. You can do this via code, actually. And so instead of trying 3 or 4, and try 10 variations of web height and see how the operation behaves. I recall in that analysis I recall in that analysis, we did that 500 operation in 8 hours, maybe. We had to run overnight, and changing the approach to the Python interface, we could reduce to 1 hour, 1 hour and a half. So we didn't need to run overnight anymore. We could correct bugs at the same day if needed. And the most important, we could increase the number of load cases and make the operation, and don't restrict the operation. So it's a good value for a client. And you do that with Python inside interface. So to conclude that, to close, I hope I have you interested in learning. And I try to summarize 5 reasons to start now. Why to start now? Well, it's a fast return investment. You learn today, you use today. You move one step up, you can optimize something that you're doing, you can do it better. Each bit of knowledge you have, you already rewarded. And so it's point number 2, any level achieved rewards accordingly. You don't need to be a specialist. If you're, okay, I want to learn something and stop here with medium knowledge, okay, you already have the benefit of that. It's accessible, it's easy to learn, it's widely documented today. You don't need to join a course, you just go to the internet, find things, and you can start. It will become more and more important in the future. As more accessible it is, more people will learn. And so, today it's an edge, but it can be a requirement tomorrow. And moreover, as I said, it's fun. Believe me, it's fun to solve problems. I don't see a reason for an engineer not liking programming, because it's what we do. We solve problems, we solve puzzles, and this is programming is all about. And is there any reason not to start? Well, yeah, there is a downside in programming that's important to mention, is that coding sometimes is very personal. So it's good because it's very flexible, but it's very hard to check. And in engineering projects, very important part of the process is the checking process. It's very hard to check. So we have to really detail what we're doing. We have to comment all the time. And, I think that this is the reason it's not widely used still today, because it's very hard to check. And I will not lie, sometimes it's frustrating. Sometimes you spend you lose many time dealing with things that has nothing to do with your problem, but with programming. And it's getting better today. Python is a language that's created to be easier, but sometimes you still lose a lot of time dealing with things that you didn't have to. So before you start automating something, you always have to wait how many time you spend coding and how many time will you save. It's not rare to get stuck with coding and spending more time automating a task that you would have spent just doing that. So, but experience makes you faster, and evolution of language also tend to optimize this, but it has to be acknowledged. And here's some reference where to start. If you want to start Python, is python.org. It's the main place. From there, you download, you install, you have the documentation there, and you have two others, I think, SciPy and Jupyter. That SciPy is that libraries for engineers, it's essential, and Jupyter is a programming environment that makes it easier to learn, to get used to. And one recommendation I do is this book, Python for Engineers. It's where I started, and it's free, it's open source. Just recommend you go there and give it a go. I'm sure you won't regret it.